how easy it's going to be to predict the species, the target variable, from the other features. This section introduced some basic concepts in data exploration, the representation in terms of the data matrix, computing some basic statistics of the data, and visualizing the data using histograms, scatter plots, pair plots for higher dimensions, and using color for classification and discrete targets. We'll begin with supervised learning problems, including classification and regression problems. As I mentioned, machine learning may be unlike much of the programming that you might have done in the past. Here, we can't simply tell the computer how to solve the problem, give it a precise algorithm to follow. Instead, we'll tell it how to figure out how to solve the problem, a kind of meta-programming task. To do so, we design a flexible program called the learner, whose behavior can be modified by changing aspects of its operation, called the parameters. The learner is a deterministic function that takes in the features of a new example and spits out a prediction for its target. This input-output behavior is a function of these internal parameters. We can then write a second program, the learning algorithm, which sets or modifies the parameters of the learner until it's doing a good job at predicting the training points that we've seen in the past, as measured by some score or cost function. Some notation is useful. The input features X will constitute all the information we have to make our prediction. For example, if I want to predict whether you'll need to go to the hospital in the next year, I might use all the information I have about you, your age, your weight, height, the outcomes of recent medical tests, etc. These are all available to me beforehand. I input them into my learner, and it outputs a prediction, yes or no, whether you'll be hospitalized. Then later, I'll find out the answer. Did you actually go to the hospital? That's the true target value Y. I call my prediction Y hat, the estimate of Y, and by comparing Y and Y hat, I can use it to determine my score. I pay some penalty or cost if I'm wrong. We'll denote the generic parameters of our learner by theta. Since data plays a fundamental role in machine learning, we'll need some way of visualizing the training data along with the results of our learning algorithm. Our training data consists of pairs of features and their associated target value, so you can imagine plotting those data. Since we can never really plot more than 2 dimensions, when we plot, we'll pretend that we have only one real valued X, and then the purpose of our learner is to map the feature value X into this target value Y. In other words, given a new feature X new, we're supposed to predict what the Y value associated with that feature would be. Hopefully something that's reasonably similar to the training data. Since it outputs a value for any X, our learner, whatever it is, defines a function from X to Y. And by evaluating every possible X, we can trace out that function to see what our learner thinks is the actual relationship between X and Y. In some cases, the shape or functional form of this function may be explicitly stated by the model, or it might be implicitly defined by the prediction program. Let's see some simple examples of this.